Hello, welcome back. We are looking at Chapter 10, Lesson 3, Lines Identification and Numbering System. Process line can be jacketed or non-jacketed lines. Normally, lines identification and numbering system in PFD or P&ID follow the standard naming convention, which may include two or more of line service code, system numbers, line service number, line size, piping service code, installation type, operating variables such as temperature, pressure, flow rate, then installation thickness. However, jacketed lines identification and numbering system in PFD or P&ID follow the same standard naming convention with additional information, which may also include two or more of inner pipe size, inner pipe operating variables, outer pipe size, outer pipe operating variables, installation thickness. For illustration purpose, find here a practical example of lines identification. Here we have a line number here, we have a line number here, we have line identification number here. Here we have line identification number, we have line identification number, line identification number. We have fitting identification example. Consider a line number with the specification HJ 10000001 10 inch 801 V 60 degree, then we have 0.22 millimeter. Here the number 1 label here is the line service code, number 2 is the system number, the third number there is the line service number, the fourth number is the line size, the fifth number is the piping service code, then the sixth number is the solution type, the seventh number is the normal operating condition temperature, then the eighth number there is the solution thickness. For jacketed pipe, if you take a look at it closely, the first number here is the inner pipe size, the second number is the inner pipe operating condition, the third number here is the outer pipe size, and the fourth number is the outer pipe operating temperature, and the fifth number here is the installation thickness. This is just for illustration purpose. Some line service code or process fluid line are the identification letter used to define the fluid type in a line. It is represented by one or two or more letters. Example of letter designation as NG refer to natural gas and O refer to oxygen. Find table 10.3.1 for some example of line service code. Take a look at the designation and the fluid type. Here we have the AG, which refer to the AG is an atmospheric vent, BD is blow down, C is compressed air, CD is closed drain, CH is chemical, CO is crude oil, CW is cooling water, IG refer to instrument gas, IW refer to service water, ME refer to methanol, and so on and so forth. These are just for illustration purpose. You can get more of this line service code from the relevant institute or organization or from the standard and code symbols. For illustration purpose, let's take a look at some practical example of process line service code. Here, for example, like we said before, the number 1 is always the line service code. Here I have my NRO. You can see is what we refer to is nitrogen refrigerant. The NG here is also another line service code. It's just the natural gas. If I have my engine, if you take a look at this label, NG, which is the line service code, is a natural gas, telling us that the fluid across that line is a natural gas. If I have my line service code, the first number as A, it means the fluid passed through that line is air. The same thing is also applied to auxiliary line service code. For practical example and for illustration purpose, here are some auxiliary line service code. Here we have the FF as the flushing fluid, then we can also have the LO as a loop oil, Then we can have the SO as our C oil. We can have BRO, for example, as brine drain as our line service code for auxiliary fluid. This is again just for illustration purpose. The same thing is applicable to utility line service code. Here we have the line service code for utility line. We can have our LS, which designate low pressure steam. I can have my HW as the first number, which designate cooling water, fresh. Then I can have my SC as my line service code, which designates steam condensate, and so on and so forth. This is for practical purpose, for practical illustration. As explained above, find another illustration of lines identification and numbering system. Imagine this as your line identification. Here the first number here is our flow type. The second number is the phase or unit number. The third number here is what we call the line number. And the fourth number here is the line size. And the fifth number is our line specification number. And the sixth number is our installation type. Let's look at the process line example 20-4 inch-GD from figure 10.3.5.2. The lines identify the process line size and piping service specification without the flow type, unit number, and installation thickness. A close look at this identification showed that it contains just few information about the line. What is applicable, what is available here, the information that is present is the flow type, the unit number or the phase or unit number, the unit number, the installation types. The information here, it does not contain the line number, the line size, and so on. Now take a look at another line here, line with more detailed information. This line has the FG NGLO 570-471-4 inch-GB-V. The figure identifies the line number, the line size, the unit number, the installations, and so on. However, the F, N, G, and LO define the flow type across the line. It shows the line is carrying more than a single fluid. Still talking about the line identification, for illustration purpose, let's take a look at the recycle, bypass, and purge stream in a line. A recycle stream is a process line that returns 30% of processed material from one process unit back to another process unit. It is the process of reusing or recovering of another material from a process or from waste stream. Sometimes it may be used to recover valuable product from a waste in a unit operation. Take a look at this one. This is a typical recycle line. As defined above, this represents a recycle line. This represents a recycle line. Bypass stream is a stream that skips one or more stages for the process unit and goes into another process unit or stage. It is a process where a portion of a flow stream is diverted around a particular equipment or a process unit. For example, a bypass line may be installed around a control valve in the flow line to allow for maintenance of the valve without interrupting the flow during operation. Take a look at this unit 1. This is a typical example of bypass. This line is bypassing unit 2 and unit 3 straight to unit 4. The purge is a bleed off stream to remove an accumulation of unwanted material that might otherwise build up in the recycle stream. It is the process of removing unwanted substance or contaminant from a unit. Take a look at the typical arrangement of a purge unit as explained already. I leave you here with quick exercises. Thank you. See you again in chapter 10, lesson 4.